One. Hello, everyone. Welcome back to our channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students that has completed the course ROS Navigation in 5 days. And at the end of this course, uh, there's a project in which you have to implement autonomous navigation to a real robot here at the construct. So that's what our student Ashish is going to be showing us today. So hi Ashish, how are you?
Yeah, hi Rodrigo. I'm fine.
Ah,
How about you?
love to hear that. Love to hear that. So yeah, whenever you want, you can start sharing your screen, and we can get started with the presentation.
Yeah. Okay. So I guess the
We see
screen
your
is
screen
got
now.
shared.
Perfect. We see the
Yeah.
robot.
So this is the real robot.
Mm-hmm.
So now basically I directly launch my RVs file. Sorry, RVs.
Yeah.
So this presentation basically we need to require the four steps. We need to complete the four steps. The first step is like these are the four packages. So the first step is like we need to map the whole environment of the real robot. So this
Mm.
is the environment, and the second step is like localization, and third step is like tuning the parameters of move base,
Right.
and then finally we need to perform some services action thing so that we can save the spot and we can move that spot using this navigation stack. I guess RVs got loaded. So now I have already created my mapping files. Here you can see in the package maps. So I have already created the map.
Uh-huh.
So I'll directly launch my move base. So so my move base, this launch file launches the my AMCL launch file, which is
Uh-huh.
in the localization. You can see here
I see.
my AMCL launch file. So this launch file launches the both map server and as well as like map server, which usually contains the information of the map, which I have mapped earlier in the mapping package.
Mm-hmm.
So AMCL totally launches MoveBase node and AMCL and also my map server. So you can see this is the map.
Oh, I see.
I guess it got mapped in a decent way. So this is my map. So meanwhile, it will get launch the whole all the parameters which I tuned in navigation.
Right.
So meanwhile, I'll explain my mapping process. Is that fine?
Yes. Let's just remember to make it quick so we can get all of the
Yeah. So
steps in
meanwhile,
there.
I'll explain my mapping and localization process. So
Mm-hmm.
I'll launch my I'll actually launch my mapping dot launch file, which actually using scan it will map the whole environment, and then in this launch file itself, it will also launch the src file, which is automatic mapping.py file.
I
This
see.
file, what will do, it will do like, once the map got ready, it will wait for the map to be available. Once it get ready, then I need to press S, so that once I need to confirm the map, how the map is done, and like how it is, it will be like, so that
Nice.
once I need to confirm it, and then I should press S to save the map. So it will automatically get saved into my maps folder in this package. So once I get completed with the mapping process, then I'll start my localization. In that localization, I'll launch my AMCL, my AMCL.launch file. In this, we need to uh, deal with these certain parameters. The main parameters are like these laser parameters and min maximum particles parameters. These localization actually deals with particle filter. So it randomly spreads few particles based on our parameters. So it will spread all the particles in random way. Once we move the robot, these guesses of the particles will come into one direction. Uh, how can I say, like, I'll show in this real robot.
Yeah.
So I guess my cost maps got ready. So here you can see pose array. I'll just enable it. So you can see the
Right.
localization. It just all the particles are there in the one direction. So
But
I'll just see this,
but they are super
my
close because you
real
set.
real robot. Sorry.
I'm sorry. I was saying they're probably super close, the particles right now, because you
Yeah, yeah,
set an initial position, correct, in your
yeah. So
parameters. Okay.
I'll just adjust my robot in this direction,
Yeah.
so that we can, maybe in this direction. So now you can see the particles are
Uh
these
huh.
gases are were in random direction.
But
So
now
now I
it's
need to
better
move the
localized.
robot to
Uh huh.
localize itself.
Yes.
So
Yes.
all the particles will be moved into one direction. So that will be the precision of our robot localization. So
Yeah.
now I'll just launch this teleop, because with this joystick I can't
Mm.
make it. I'll just launch this launch.
Yeah. I realized
Now you can see.
if you spin it in both
Yeah.
directions, that's sort
So
of the best
yeah, yeah.
way.
If I spin in a rotation way,
Yeah.
so the robot get localized a very good manner. So you can see within few seconds it got localized.
Now everything's lined up. Nice.
Yeah. So I guess this will be enough. So I'm stopping this uh, teleop, because once I give the navigation goal, then the teleop must be in disable condition, because it will block the whole navigation process.
Hmm.
So the cost map got ready. You can see both local cost map. This is my global cost map, and this is my local cost map. My local cost map. Mm, now I'll send a goal this direction.
Oh wow. Yeah. All right. So it Looks like it already got there, no?
I guess it reached its goal. Yeah, yeah. Goal got reached.
Nice. Yes. So now we know this navigation works.
Yeah, everything got work. So I'll try once again. So you
Uh-huh.
can see the robot got moved
Mm-hmm.
to its goal position. Sometimes it keeps on adjusting because of the goal tolerance issue.
Yeah.
It will just be something like in a confusion manner because the goal tolerance of xy and also rotation part.
Mm.
It should manage both the part. So I guess goal got reached. Yeah, goal got reached. So now this is the whole navigation process that I have done in this navigation package. So before going to this whole parameter thing, I'll just want to share this path planning also. This path planning
Yeah.
actually, what it deals with, like I have saved few spots in localization itself. I'll show that. So this is a spot to file, like I need to save the spots of robot, and these spots will be used by this path planning package. So once I launch this package, sorry, not path planning, sorry, my bad, navigation, sorry, navigation package. Once
Uh-huh.
I start launching this navigation launch, then if I call the service, which is I have created get coordinate service. Once I call the service with giving a certain point spot, it will reach that spot using this whole navigation process. So I
Right.
want to show that too. So I'll just launch the navigation.launch file. Hello, hello.
Yeah, yeah.
Yeah, okay.
Sorry, there was
So I'm launching my navigation.launch file. So it gave the prompt like starting get coordinate service. This service I have created in this package. So once the service got started, now I need to call the service.
and then the name, right? Of what it, yeah.
Yeah. So before saying that, I have already saved few spots in the YAML file, which is corner one, corner two, maybe this corner and this corner. I need to check. Also, I need to once again save these spots.
Yeah.
So I have gave corner one. So calling move base,
Uh-huh.
and I guess yeah, this is a
Yeah, yeah.
corner one. So that is a robot got moved to that position. And okay, fine. Now maybe I'll save one more spot, which is pedestrian spot, which is this spot, and then I'll run once again.
Yeah.
So meanwhile I'm shutting down this service, and I'll just uh, call this spot.launch.
Mm-hmm.
Sorry, I'll just launch the spot.launch file so that I can save the spots. So So before you that, I need to also mention this. So before I have mentioned like I need to go to corner one. So it got successful. So
Yeah, yeah,
process got through
that's when it
and
went. Okay.
parameter sent to move base message and this. Yeah. Now AMCL topic getting this launch file getting data from this AMCL post topic. So now I need to send a corner. Before that, I'll just align this corner to here, which is pedestrian part,
Uh-huh.
so that I can save this spot.
So you can say, yeah, okay.
Mm, as it got moved to pedestrian. Yeah, goal reached. So now need to just call the service ROS service call.
I think
Sorry,
you missed the space. Yeah.
save spot. And I need to mention the spot label, which is pedestrian. I need to save it. Yeah, pedestrian saved. And
Awesome.
before that, I need to uh, save the whole position and orientation of this spot to the YAML file, so that I need
Uh-huh.
to uh, label it as N, so that it will get saved and the navigation successful will be get as true. So uh, this text file, YAML file. Yeah, now you
And
can
that's
see
the one.
pedestrian.
Okay, that's the one we just
Yeah, only one I
saved.
just saving. So I'll start from here and then I'll move to pedestrian.
Uh-huh.
In my case, I don't know the actual issue, but the speed of the robot will be very low.
Very low, you said?
Yeah, like
Yeah.
okay. So now I'll just start the service, this navigation service. So I'm just launching the launch file of this navigation and I'll just start the service of get coordinates. Once I get the get coordinates, I'll just do the service call for the pedestrian.
Mm-hmm.
Yeah, so starting get coordinate service and then I'll just launch. Sorry, I'll just call this service label of pedestrian, and I guess
There you go.
now you can see the robot is moving.
Uh-huh. And it's eventually gonna end up at the spot you saved.
Yeah,
All right. Well, looks like it was gonna crash, but it didn't.
maybe it's a recovery.
Right. You can see all that output in the terminal
Okay,
of
okay,
what's
okay. It's
happening, right?
getting moved.
Yeah, yeah. At least we know we got the correct command. And it's
Sorry.
just trying. I'm saying at least we know it understood the saved spot, and now it's
Yeah,
just
yeah,
trying to get there.
yeah.
Now, that's if whether it makes it or not, that's another question. But that's awesome. Looks like it got there already, huh? Hello? Hello, hello? it looks like we might be having some connection problems with Ashish. Um, let's wait a couple of minutes because I can see his screen froze, so I'm assuming maybe he lost internet connection. But yeah, basically, what he was showing us was the whole process of what he had to do in this project and basically make a mini application for autonomous navigation. So it's a two-step process in this project is to set up move base and AMCL, which is the navigation and localization system for this robot. And then after that, use some programs that Ashish wrote to sort of identify locations. And it looks like he might be coming back in soon. So, yes, identifying locations and then moving towards it. I think he's coming back.
Hello.
Hello, Ashish.
Yeah, yeah. Sorry. It's due
Don't
to
worry
power
about it.
cut in my
I
area.
I figured you sort of missed connection, had connection
Yeah,
issues.
yeah, yeah, yeah.
But don't worry. Are you able to keep sharing your screen? But honestly, I think uh, we saw the whole project basically because we were watching it go towards the pedestrian. Oh, there you go. Let me just go back to your screen.
Yeah.
All right.
So see,
Yes.
the pedestrian navigation successful true and the parameters sent to MoveBase. This
Right.
is a message.
Awesome.
So
I was.
now,
Yeah.
mm,
Go ahead.
now I need to explain the navigation process, which the code of the whole service and action client. So I'll go through it. So uh, the basic navigation launch, this launch file consists of like uh, loading the parameters file, which is a YAML file which I have saved the spots in localization process, and also it will start the node of the service node, which is get coordinates node. And then I'll just go to src files. So this is a service file which is get coordinate service. So these are the few in imports. In this service file, I have created a service message, which is nav message, which consists of string input, which is a label like corner one, corner two, or pedestrian, which is a string input. And then I have to give response like navigation successful, which is a bool, true or false, and then message in terms of string, which I have seen parameters sent to MoveBase.
Mm-hmm.
So these two are the messages and like result messages. And
Right.
then I'll go to get coordinate service file. So in this we need to start the service server, which is get coordinate service. And once the service got started, we need to call the service, and it consists of service callback, which will have an attribute like request, which we need to provide as a label. So this request will be processed in this whole service callback. So once the label got requested, this um, ROS param, which I have loaded the parameter file. So those parameters will be loaded, and that will be go to this corner variable. And then both the label and the corner variables we need to send to the send coordinates class, which is in my action client class. So I'm just importing that class from this file, which is a send coordinates action client file. So basically this action client file actually have classes send coordinates and which have inputs like label and goal point. So the label is basically corner one, corner two, or pedestrian. Goal point is like coordinates, uh, coordinates like position and orientation.
Right.
So I created a goal object of this move base goal, Before that, I need to check whether the move base started or not. So this client will uh, like use this move base topic, which the whole process will be run, like whole the navigation process will be run. So this client should send the goal to the move base. So for that, I need to I use this while loop. In this, I will update the whole goal point positions of x y z direction of the position, and also orientation of x y z and w, which is
Mm-hmm.
quadrillion point maybe. Yes. So, and then I'll just send this goal position of the whole what label, which I have saved in the YAML file. So this goal will send to this uh, move base. So once the goal has sent, I need to check the result. If the result got 3, then the result is successful from the maybe from the ROS debugging thing. So once the I get the result is 3, then successfully reach the goal, which I'll print in the uh, command prompt, and then that's it.
Okay.
That's it.
That's the whole
Uh,
that's the
and the,
whole pipeline
and
then.
then the service message will be get navigation successful will be true, which here you can see. Once I send the send coordinates, this service will wait until uh, the result will until gets a result. Once it got result, it will go move to next step. So once it gets result, in this condition there is no particular return value. So but once the whole process done in the action thing, then it will get it will get move to further process. So the navigation will be successful, and then it will return a response. That's it.
All right. Well, that's all the pipeline for you guys. Thank you, Ashish. Really clear, really well organized project. So let me just ask you one question. Sorry, I messed up there. Do you think that you could basically great? I love your project, really clear. Everything was achieved there. So my only question would be, how would you improve the fact that it looked like the movement of the robot, um, one was sort of like stop and go, and the fact that it wasn't finding it sort of as quick as you would expect, right? That sometimes
Yeah,
it took a
yeah.
little while for it to get there. So why do you think that is, and how would you try and approach that, if possible?
Maybe I need to tune this update frequency and publish frequency
Yes, I believe that's
of the
one.
cost map.
I believe that's one of the ways you could do it for the plant for the controller. That's for the movement. It looks like the control loop might be either too quick or too slow.
Maybe control frequency.
Yes, and then there's uh, I would say a lot of reasons why some system could not find a goal as quick as it could. But I would say the main reasons usually is either the inflation radius
Yeah, inflation
or
rate.
having trouble localizing, in which in this case, in this scenario, is a little hard because of the nature of
Yeah,
the
small
environment.
small
It's
environment.
small and sort of symmetrical.
Yeah,
But yes, you're right. It would be a matter of tuning the parameters there, and hopefully that makes a difference. But I mean, Ashish, other than that, I thought this was a great project. So I want to congratulate you, and
yeah.
and great job.
Thank
And
you. Thank you.
And for everyone else that's watching, that's it. That's it for us, guys. And you can do this as well when you take our courses. You can present them to show that all of what you've learned and to obtain your learning certificate. So I invite everyone else to do what Ashish did. So that's it for us. Thank you, Ashish. We'll see you later.
Thank you, Rodrigo. See you
Okay.
again.
Bye bye.
Bye.
All right. We're done.